Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this related rates word problem. As per the problem, water is pouring into an inverted right circular cone at a rate of 2 pi meter cube per minute. The height and the diameter of the base of the cone are both 10 meters. How fast is the water level rising when the depth of the water in the cone is 8 meters? The first step is to draw a diagram for this problem to understand what's given and what we need to find. As per the problem, water is pouring into an inverted right circular cone. So let's draw an inverted right circular cone. The height of the cone is 10 meters. The diameter of the base of the cone is 10 meters. That means the radius of the base is 5 meters. Water is pouring into this cone. Let's assume the height of the water in the cone at time t is h. Let's assume the radius of the top surface of the water is r. As water is poured into this cone, the height or the value of h increases. Also, the value of r increases because as the water level rises, the size of the top surface of the water, which is in the form of a circle, increases. As a result, the value of r or the radius of that circle increases. This is a very important concept we need to understand and memorize to solve this problem. We are given that water is pouring into this cone at the rate of 2 pi meter cube per minute. That means dV over dt, the rate of change of volume of water in the cone, is 2 pi meter cube per minute. There is a very important concept we need to understand. We have to find how fast is the water level rising. That means we have to find dH over dt, because h represents the height of the water in the cone. Since we are given the rate at which the volume of water is increasing in the cone and the water takes up the shape of the cone, we should analyze the formula for volume of cone to solve this problem. The formula for volume of cone is 1 over 3 pi r square h. In this formula, we have three variables v, r and h. As water is poured into the cone, the values of v, r and h change because as more water is poured, the volume changes, the value of r changes, and the value of h also changes. Since we have to find dH over dt for this problem, we should do the substitution for r in terms of h in this volume equation. For that, we need to analyze the diagram I drew on the board. In this diagram, we can draw two triangles triangle ABC and triangle ADE. These two triangles are similar triangles because angle A is common to these two triangles and angle D is congruent to angle B because both are right angles, because this is a right circular cone. As a result, triangle ABC is similar to triangle ADE as per the angle or AA rule of similarity. This is a very important concept we need to understand and memorize. In similar triangles, corresponding sides have the same ratio, and in these two triangles, the corresponding sides are AB and AD, and this ratio should be equal to BC over dE. We can use this equation to find the value of R in terms of H, because we want to do the substitution for R in the volume equation to find dH over dt. AB is equal to H, AD is equal to 10, BC is equal to R, and DE is equal to 5. We can use this equation to find R in terms of H. We can isolate R on the right side of this equation by cross multiplying 5 to the left side of the equation. Five times H over 10 is equal to 5H over 10, which can be reduced to H over 2. We can use this equation to do the substitution for R in the volume formula. We can simplify this equation. H over 2 square is equal to H square over 4. We can multiply 3 and 4 because they are in the denominator. This is the formula for volume in terms of H. Now we can find the derivative of the terms in this equation with respect to T. On the left side, the derivative of V with respect to T is dV over dt. On the right side, 1 over 12 pi is a constant. It's the coefficient of the term, so it will stay as it is. We have to use chain rule to find the derivative of h cube with respect to t. The inner function is h, the outer function is exponent 3. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent to the front of the term and subtract 1 from 3 in the exponent times the derivative of the inner function h. The derivative of h with respect to t is dH over dt. Now we can simplify this equation. 1 over 12 pi times 3 is 3 pi over 12 h square. We are given that dV over dt is 2 pi. We can reduce 3 and 12. We have to find how fast is the water level rising when the depth of the water in the cone is 8 meters. So we should sub in h as 8 to find the value of dH over dt when the depth of the water is 8 meters. There is a very important concept we need to understand and memorize to solve this type of problem. Eight square is 64. We can reduce 4 and 64. Next, we should divide both sides by 16 pi. The pi's cancel each other out and we can reduce 2 and 16. I get dH over dt equals 1 over 8. And the unit is meters per minute because the unit for dV over dt is meter cube per minute. This should be the final answer for this problem. So these are the steps we have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.